thing. So the lesson today is just like a part 2 of the lesson that we did yesterday. And it's when your exponent is a fraction. And what we do for that, right? So we've got some rules. If your number is raised to a rational exponent, and it's a radical, such that if we've got b to the power, I see AirPods. Ryan, take your AirPod out. Please and thank you. Ryan, AirPod out. All right? This is your last opportunity to take AirPods out and put your phones away if you are on them. All right? So if we have b to the power of a fraction, this is really like saying the square root of b to its nth root. Okay? Nth root. Right? If we've got something where, so that would be like, for example, 1 over 2 or 1 over 3, right? Nothing is joining b in the square root. So we just have whatever's the denominator, it's sitting on like the little hat of the square root here, right? Versus if I've got something that's b to the power of m over m, so I've got 2 different numbers in my fraction, this is going to look like n, but b to the power of m. So m gets to join b in the exponent, or in the square root, I should say. The n is on the outside, so it's telling you what kind of root it is. It is a square root? Is it a cube root? Is it a fourth root? Is it a fifth root? Hold on, yeah.
What if we put a numerator? What if the numerator is the number? Like the autumn, like there's like. What if
We're
M
gonna
is on top and there's like a number below it?
M is on top and n is in the
There's
top?
like a number below, like 1. Then what
So
do we do?
it'll be a fraction. It has to be a fraction. I'm talking like 2 over 3, 4 over 7, nothing over 1, because then that's just itself, right? Okay, peeps. So the index, right, which is the fancy thing, the n that's sitting on top of the square root thing, is just telling you, so it is number left to the radical, or you can say n on top of the radical. Radical. And it tells you which root to do. Right? And e.g., that could be like, if it's a 2, that equals square root. If it's a 3, that means cube root, and so on and so forth. Right? So the number there is just telling you, like, on your calculator, you can cube root, you can fourth root, you can fifth root on here, right? So that one's telling you essentially how many times are you going to, like, root this number. Okay, so don't be alarmed. We're going to practice this. Okay, am I good to start? Okay, for example, if I've got 49 to the power of negative 1 over 2, first thing I got to address is the negative, because negative means what? We're banishing it to the basement, into the denominator. So this is really like 1 over 49 to the power of 1 over 2. Right? So first step was putting it in the denominator because it's negative. Now once it's there and it's a positive root or a positive exponent, now this is when I change it. So remember, the denominator of the fraction is sitting on top of the radical. So this is really like 1 over the square root of 49, which you can square root 49. It is a nice number. It is just 7. So this is really 1 over 7. Right? Even if you want to like make a little highlight or like a little note of like, okay, denominator is the thing that goes here. The 1 just went under the square root with 49, but we don't say something's to the power of 1 because that's just itself, right? So we don't need to write the 1 there. Okay, even with this one, we've got brackets around it. So we've got negative 8 to the power of 1 over 3. I don't have any negative exponents or any negatives in my exponent, so I don't have to adjust that. But I need to change this to a radical. So again, bottom number is the thing that is sitting on the radical. So this is going to be 3 and then my base goes underneath, I don't need to write 1. So this is the cube root of negative 8, which, if you do this in your calculator, you get negative 2. You cannot square root a negative number, but you can cube root a negative number. So this is equal to negative 2. Because negative 2 times negative 2 is positive 4, but then times negative 2 again makes negative 8. So it's that idea. If you've got an odd exponent, you can root that as a negative number. So like 5th root a negative number, 7th root a negative number, 9th root a negative number. We're not going to do that high, but you could. Yeah, Manoli? Usually, if you have a calculator, you press shift and then the square root button, and that will give you a cube root. Try that. Shift and square root. Right? And then if you do negative 8, it'll give you negative 2. Shift and then square root. Okay. What about this last one? I've got 10,000 to the power of 1 over 4. What root am I doing? I'm doing the 4th root of 10,000. I'm going to fact check you just to make sure. So 4, Ali says is what? 400? I get 10.
I got 400.
I would check that. This is just 10. Because then 10 times 10 times 10 times 10 is 1,000.
I got 400.
Because you're doing 4 times the square root of 1,000. You're not doing the 4th root. You're just doing 4 times the square root. Okay. How do we feel about that? Yeah. Most calculators should also have a button that has like a blank space for the radical. So I press that, and then I can input 4th, 5th, 6th root. So yeah, shift that root. But I don't know how to change that. And then I think you would change that to 4.
Yeah, that works.
This gives us the x root, but I don't know how to change that. Okay, maybe we have to do it like that. So the 4th root of 10,000, 10. So you just press 4 and then this root. So that's the 4th root, okay? Yeah. Okay, so moving on to the next one, because Kira was like, well, what if I have a 2 in here? How is that going to work? He didn't ask it. You put your hand up and then he turned away. And then you interrupted me and you intercepted me. Okay, what's your question? Yes, so if you just go ahead and put this in your calculator, that is not showing your work. You need to show your work to gain full marks on a test. So you need to convert it to a radical. Yes, you do.
There's 3 outside.
So for example, this one, yeah, you can put 27 to the power of 2 over 3 in your calculator and get the answer. If you just put the answer, you are not getting full marks. I need to see that you can convert it to a radical. That is showing your work.
Would this be showing your work?
Mm-hmm. Can I continue on with the lesson? I don't know if I can. Am I good to go? Cool. I'd love to continue teaching. So, same thing. This is what's sitting on the radical. And then this is going on the inside. So I'm doing my color coordination. I'm going to do blue and yellow. So if I've got a square root, I know that my denominator, what's in blue, has to sit here. And then this is 27 squared. Which then, if you did 27 squared, you get cube root of 729, which just gives you the cube root of 729 is 9. I gotta make sure.
So we have to go through all three of them? Can we do like the first one and the last one?
Right? Alternatively, you can also do, which is equivalent, the cube root of 27 and then square that. That is also the same thing as saying like the 27 squared and then cube rooting that. It's the exact same thing as saying the cube root of 27 and then squaring that answer. You'll get the exact same thing because the cube root of 27 is 3 and 3 squared is 9. Right? So if you can't figure out how to do like the cube and the 2 in your square roots on your calculator, you can do it separately like this. You will get the same answer. Right? If you have an ugly decimal, convert that to a fraction. We cannot put decimals in radicals. That does not work. So what is negative 0.75? Pop off. Exactly. So this is really like, here, I'll write it properly, 16 to the power of negative 3 over 4. Right? Which one's going in my top? Which one's going in my bottom? Or do I have to do something first?
You can see.
Because it's negative. You good? So because it's negative, I gotta flip it first.
What? Are you?
It's negative. I have to flip it. Oh, what am I doing?
Yeah, that's
I had a blonde moment. I'm sorry. No offense to the blondes. Oh my God. Okay. 1. I did say I just had a blonde moment. 6. I don't need this extra bracket. Oh my God. I'm so off my part today. 16 and then 3 over 4. That's what I meant by flipping. I just flipped my brain upside down. I was like, what's wrong with that? I need a nap. And then we can put it in our root. So this is 1 over 4th root of 16 cubed,
we got 8.
which I'm going to do it step by step, Lucas. I'm not going to rush. So the 4th root of, if I do 16 cubed, this is 4,096. This conversation does not sound productive at all. It doesn't. And I think you got to focus. And then 4th root of 4,096. We get 1 over 8. Because it's negative, we put it in the denominator. There we go. That's it. Last thing is combining. So now, if you are multiplying, dividing, and you've got a radical all in one, which is what we're doing next, 3 or 4.4 is long expressions like this with multiple variables and simplifying. So this is what's uncupping. I don't think it necessarily is easier first. Let's just try it. Let's just jump in. Okay. Perfect. First thing, okay, are we good? It's so hard, to teach. You guys feel like my grade 10s today. I can't get in a peep. I've got one person criticizing my teaching, telling me how I have to teach the lesson. I've got people talking over me. It's really hard to teach today. I'm trying to help y'all. Okay. Are we good? I don't want to leave you with this on your own because this looks scary if you've never seen it before. It looks terrifying and it's only going to get worse. More terms are getting added to this in 4.4. So that's why I want to do it with you. I want to walk through it with you, but I can't. Okay. First thing, If you see a radical, get rid of it. We do not want the radical. We're going to convert it to an exponent. So my first one, I've got 8, 5 to the power of 6. And then this is saying times the square root of 8. What could that look like? We said if we've got a square root of something, if this is like 8, ooh, that looks bad. Right? How would I convert this going backwards? Using the rule on your front, on the front page, the first rule we did together. If we said we've got an exponent to a fraction and it's 1 over n, then it's the square root of n. So if I've got square root of n, or square root of 2, this is just going into the reverse. This is just turning it into a fraction. If you don't see one, automatically assume it's a 2. Because you're square root. No, you can't do 1. It's always a 2. So if you don't see something there on a radical, it's a 2. So really, square root of a number is just 1 over 2. So this is like saying 8 to the power of 1/2. And then all over 8 to the power of 5 over 3. Which, okay, I want to do my multiplication exponent laws first. They're all bases of 8, so I can just put this together. So if I'm multiplying, I'm going to do what with their exponents? Yeah, Bridget?
Oh, I have a question.
Yeah.
How did you get
The 1/2?
Yeah.
So if we flip back to this rule, and we said, if this is like our ending point, if we've got a square root of a base, and this is our radical on the end, then we know we're going to flip it to a fraction.
Oh, we go back.
You go backwards, essentially. So it's using this rule, but now you're just flipping back. Right? So that's why anything square root is just 1 over 2. Just like if I had cube root 8, what would that look like as a fraction? 1 over 3. Fourth root, 1 over 4. Right? So, okay, first thing I got to do is what? Am I multiplying or am I dividing first? I should multiply. So I got to add those exponents on the top because they're both bases of 8. So this is like 5 over 6 plus 1 over 2. You could, on a test, I don't care if you use a calculator for this, just show this. Just show me that you're adding them because you know the law, that you can add them together, right? You can use a calculator for that. I don't mind. Right, which gives you 4 over 3. So I'm just going to continue this on here. So 8, 4 over 3, all over 8, 5 over 3. Now that I'm dividing, I can subtract. What'd you say it was, Lucas? -1 minute? Oh, yeah. 8, -1 over 3. Can I leave it like that? I cannot. We do not like we do not like negative exponents. So I gotta flip it as my final answer. All right, so this is really 1 all over 8 to the power of 1 over 3. Which then I have to evaluate. What is 8 to the power of 1 over 3? I could also write that as the cube root of 8, right? You could switch it, or you can do in your calculator. 8 to the power of 1 over 3 is 2. I'm going to walk through it again. Don't worry. I'm going to walk through it. It's just 2. The cube root of 8 is 2. Oh, there you go. Yeah. 2 and then 2 root 3. What is that? Okay, hold on. We'll check that out after. Yes, Ryan. Yes. So, first step was getting rid of the radical. So anytime you have a radical, you have to turn it into a rational exponent. So you have to use that rule where you can flip back and forth. Once you have that, you can do your exponent laws. So that's why I added these two exponents together, because they're both a base of 8. Back table. Thank you. I added them together, which gave me 4 over 3. And then because I'm dividing, I can subtract their exponents. So 4 over 3 minus 5 over 3 gives me negative 1 over 3. I cannot leave a final answer in negative exponents. I have to leave all answers in positive exponents. That is a rule. So I know with a negative exponent, I gotta kick it to the denominator. And then this step, not totally necessary. I would say it's good to show that like you're cube rooting. That I think makes more sense than 8 to the power of 1 over 3. But I just switched it back to a radical. And then I know that the cube root of 8 is 2. Again, you can use your calculator for this heavy lifting, right? But if you just did this all in one shot in your calculator and wrote it's 1 over 2, that gets no marks. Yeah.
So let's say, for example, we didn't go this route, we decided to do, then would it be possible to work with it as square roots instead? Like we for example,
Yeah.
because it starts out with 8 5 over 6,
Mhm.
we make that fifth root or whatnot.
Yeah.
We just work kind of that way.
But we don't have square root laws.
So you can't.
How to combine them square root wise. It doesn't make sense. We have exponent laws of how to merge their exponents, but square roots, no.
It's just a word, basically.
No. Yeah, you want to get out of radical form.
Technically, you can do it and you will get the same answer.
I don't know how you would do it with combining square roots, considering there's no square root laws. You can't combine like a cube root and a fifth root to make an eighth root. You can't do that.
Yeah, I mean, if you still multiply them.
Not from a square root form. That's why we convert. I'd like to see like your method, right? Same thing. Why don't you try this since y'all seem to have got it on the chat? You try it. It's a lesson. It's not a test. Relax. If you get it wrong, you erase it. It's okay. Try it. Take the training wheels off. Notice, what are your bases? X is a base. Y is a base. You cannot put X and Y together, so be mindful of that.